All right, 9.1. This is just like a refresher video for our asynchronous class today. Just real quick, I want to go over the parts of a parabola. So anytime that we're working with something to the second power, so like x squared, so the formula or the functions and equations we've been seeing have been like y equals x squared plus 3x plus 6, something like that. So we have these trinomials. And when we graph these, they end up creating what we call a parabola, which is this U shape. And there are some important parts of the parabola. The x-intercepts are where they cross the x-axis. And because the parabola makes a U shape, it crosses the x-axis at two places. It is possible to have it where it only crosses at one point, like right here, where it just hits the x-axis and then bounces off. And then it's also possible to have it where it doesn't touch the x-axis at all. We also have the y-intercept, which is where it crosses the y-axis, and that happens only at one point. And then some more important pieces that we're going to be working with today are the axis of symmetry. And because this is a U shape, the axis of symmetry acts like a mirror. So think about this point here is 1, 2 places away from our axis of symmetry. And because it acts like a mirror, we know that there will be another point 1, 2 spaces away on the other side. And that's true of like every kind of part of this line, but only some of the parts are on exact points. So these are on exact points. Here's an exact point, so I know that one away from that would be right here. So the axis of symmetry is like a mirror, and if I go one point to the left of our axis of symmetry, I'm going to get a value that is the same as one point to the right. So here's our axis of symmetry at 1, like x equals 1. And so if I go one number smaller than that, so let's see, I'm going to create an x and y table, and I'm going to go, okay, a number smaller than 1 would be 0, and then the next number smaller is -1. And then if I go larger, I have 2 and 3. And so here's what we'll see. And actually, we don't have enough room to see these two sides of things, so I'm just going to work with these three numbers here. At 1, we have a point down here of -1, 2, 3, 4. So -4. So 1, -4. At 0, which is here, I have a point of -3. Which means at 2, because it's reflected, here's 1, 2, I should also have a point of -3. So today we're going to be looking at how to find the axis of symmetry. We're just going to see some examples on that again, and then we're going to build some tables using our axis of symmetry and reflecting to find our values. So let's jump down here to our axis of symmetry. The formula is, first of all, this is written in standard form. So we have our A value, which is 1, because it's 1x squared, our B value, which is -8, and our C value, which is +12. So our formula here is -b over 2 times A. And I like to write our formula with just parentheses, -b over 2 times A. And so I can fill in my values. B is a -8 and A is a +1. And then we can evaluate. So a negative on the outside means the opposite of. So the opposite of negative 8 is positive 8 over 2 times 1, which is 2. And then if I reduce 8 over 2, I get 4. So our axis of symmetry is x equals 4. And that is a line. So if I have a parabola here, our axis of symmetry is this dotted line that goes through 4. 1, 2, 3, 4. Okay, let's see another one here. So our formula, negative b over 2a, which means negative 2. So I'm going to replace my b with my b value, which is a negative 6, and my a with my a value, which is a 1. You're going to find for all of these problems, we're working with an a value of 1, just to simplify things. So the opposite of negative 6 is positive 6 over 2 times 1, which is 2. And 6 over 2 reduces to 3. So x equals 3. Again, if that were on a graph, we would have our parabola. And that would be a line going through 1, 2, 3. So it's a line going through our third place. And that means that every point is going to reflect across that line. It's a secret tool that's going to help us later on. Okay, so here's another one. Negative b over 2 times a. B is an 8 and a is a 1. So negative 8 over 2, which is negative 4. So x equals negative 4. So on this one, if I had a graph here, negative 1, negative 2, negative 3, negative 4, that's where my axis of symmetry would go through, and then I would have, if I had a parabola, my points would reflect across. They would be equal on either side, okay? So let's jump down here, and I'm just going to show you some practice problems. So we are going to find the axis of symmetry. That's using negative b over 2a. And then we're going to use that to create a table with 5 points, an xy table. So check this out. I know I'm going to need an xy table. I'm going to use that, write this over on the side here. And I'm going to need 5 points. I know I need to use negative b over 2a. So I can solve that out now. Negative 2 over 2 times 1. So this is going to give me a positive 2 over 2, which gives us a 1. So we use this because this is our middle point on the parabola. We use this as our middle point for our x values. So I'm going to say 1 is my middle starting point, and now I'm going to build around that. So I'm going to say 2 numbers smaller and 2 numbers bigger. So let's go with, and you don't guess the numbers, you just count in order. So I'm going to go 0 and negative 1. I'm going to go 2 and 3. So this should count in order. Negative 1, 0, 1, 2, 3, like a number line. And now we're going to solve, but we only need to solve for 3 of these. So when I say solve, I mean we're going to plug in 1, evaluate, and then whatever we get out, we're going to list in our table here. I'm going to plug in 0 and evaluate, and whatever I get here, remember, it's going to reflect over onto the other side. So whatever I get from my blue value up here, I can use down here. Same thing, I'm going to plug in a negative 1, and whatever I get here, I'm going to get to use down here. So I only have to do 3 equations, and I'm going to do these. I'm going to plug in for these. So I'm going to create 3 boxes for me to do my work. And I'm just going to take this equation and I'm going to write it with the x as parentheses because I'm going to replace the x with different numbers. And you could go through and do this for each box. So that's parentheses squared minus 2 times parentheses minus 2. Same thing here, parentheses squared. So all I've done is instead of an x, I've written it with parentheses. And now I'm going to plug in my values. So I'm going to plug in my 1. I'll do that in red because it's highlighted in red. I'm going to plug in a 0. I'll do that in blue because that's highlighted in blue. And I'm going to plug in a -1. I'll write that in purple because it's highlighted in purple. And then I'm going to evaluate each one. So I'm going to say 1 to the second power. That means 1 times 1, which makes 1. And then I'm doing -2 times 1, which makes -2. And then I'm going to take this -2, and it's not really being changed yet, so I'm going to just bring it down. Now all I have to do is add all of these up. So I have, or follow my sign rules to combine. So I have a -2 and a -2, which make a -4. So I have 1 minus 4 if I put those together. And then 1 minus 4 makes -3. So when I plugged in a 1, I got out a -3. Let's see what happens with my other ones. For my blue equation over here, 0 is always the easiest. 0 squared makes 0. -2 times 0 makes 0. So whenever we're using a 0, we always just end up with our last number. So that's going to give me -2. And remember, it reflects across. Because we found our axis of symmetry point, we were strategic. This -2 reflects across, and I can write it down here as well. And now let's do the -1. So -1 squared is 1. -2 times 1 is +2. And then I'm subtracting 2. So if I put these together, that makes 0. So 1 plus 0, which is 1. So when I plugged in a -1, I got out a +1. And that's how we fill out our table. I'm going to give you one more example, just to keep this video short. The whole idea is that we first find our axis of symmetry by using our formula, -b over 2 times a. So my b value is 4 and my a value is 1. So this becomes -4 over 2, and that becomes a -2. So we find our axis of symmetry, and we use that as our middle number. And then we're going to find two numbers smaller. We're not going to find them, we're going to use. So -3 and -4, and two numbers bigger, -1 and 0, if you think about a number line. So we just want it to count in order, and we want this value, our axis of symmetry, to be our middle value. And then we're going to plug in our values into our original equation and see what happens. So my original equation, x squared plus 4 times x plus 5. But I'm going to be replacing x with some different numbers to see what happens, which is why I'm putting parentheses. So number squared plus 4 times the number plus 5. Now, we have to use the middle term. We have to use this one. So I'm going to use this one here. So I'm going to plug in a -2 and a -2. And then it's our choice. I could either use 1 or 3. I mean -1 or -3. Because either one that I use, I'm going to get the same answer. So I just have to pick. I'm going to choose -1 just because it seems a little bit easier to work with. So I'm going to find out what happens when I plug in a -1. And I would get the same thing if I plugged in a -3. So I get to use that value for both. So I'm going to plug a -1 into this one. And then the same idea between the -4 and the 0. Just like the last problem, 0 is really easy, so I'm going to use 0 again. I'm going to plug in 0 and find what I get, and then I'm going to use that same value up here. So let's go ahead and just start at the top box. Negative 2 times negative 2 is a positive 4. 4 times negative 2 is a negative 8, and then we're adding 5. So the process on these is like pretty similar. We square the first number, we multiply the second set, and we bring down our last number. And then we just combine all of these. So when I combine, if I do 4 minus 8, that makes negative 4, plus 5 makes a positive 1. So when I plugged in a negative 2, I get out a positive 1. Let's see what happens for our blue. So negative 1 times negative 1 is positive 1. 4 times negative 1 is negative 4. And we're bringing this 5 down. So 1 minus 4 is negative 3 plus 5. And that's going to give us 2. So when I plug in a negative 1, I get out a 2. And that reflects across our vertex, our axis of symmetry, which is in red there, that middle point. And then finally with 0, 0 squared is 0, plus 4 times 0, which is 0, plus 5. So we end up just getting 5. So that's going to be 5 there and 5 there.